Today's talk we'll look into how to build data pipelines with Cask Hydrator. So data pipeline is a very kind of vague terminology, so we'll try and kind of define that a little bit. So data pipeline provides an ability to automate complex workflows that involves maybe fetching data, most likely from disparate sources. Maybe you have some data in S3, maybe you have some data in some database, RDBMS, or Hadoop HDFS. And then you want to perform some non-trivial transformations that might include simply just dropping certain fields in the records, or you want to group them or combine them, or you want to build some models and then classify some data. Basically doing some sort of non-trivial transformations, and then you're trying to derive insights from the data. So let's take a little bit of concrete example. This is one of the typical use cases that we see usually analyzing web access logs. So let's say you want to fetch web access logs from Amazon S3 every hour. You want to load it into your Hadoop cluster. Let's say you want to just for backup purposes. At the same time, you want to also perform analytics so that you can do some real-time reporting. For example, in this case, we want to find out the number of, from the web access logs, we want to find out how many requests were successful, how many requests were failures. And then let's say you want to also get some insights into what are the different browsers that the clients are using to access your web pages. So if you think about it, if you're developing this particular application on top of your Hadoop environment, let's say a Hadoop distribution, now the challenge is that usually people have a bunch of different scripts, of ETL pipeline scripts that they've stitched together. It's very hard to maintain because you have to use different Hadoop components in order to build this end-to-end application. And so you may not have developers who have enough expertise in all these different technologies that is essential to build this entire use case. And essentially what ends up happening is it's pretty much very hard to debug and validate, and then it's pushed to the production environment where it frequently fails, and so it's very it's not really nice really. So this might sometimes resonate with some of you. It's something that we see often in the industry. So we are taking this opportunity to, let's say, do a little bit of a demo where we actually load some logs files from S3 into HDFS and also want to perform some aggregations and analysis. So we have some web access logs stored in Amazon S3. We want to fetch them, store it in HDFS, and also at the same time we want to pass them into individual different fields. We want to find out the distribution of the status codes, the response status codes, and then we also want to find out the most commonly used client browser. To give you an idea, this web access log looks like this. This is just one single web access log, and so the different fields that represent our IP address, let's say HTTP status, response status, and then the client browser. So I'll switch to the demo. So this is Cask Hydrator. So what you see here is basically the Hydrator Studio where I can build my pipeline. So as I mentioned, we are going to fetch some data from S3, and I have populated some of the information that's required. For example, the access ID, the path, the access keys, and so on. So I don't want to type all that right now. And now the first step was that we wanted to process that in a file set. So I take my sync, which is a time partition file set, and it's being stored in Avro format. So let's configure that. We'll just name this as raw logs because it's just the actual logs itself. So let's say we name this as raw logs, and we name the pipeline to be raw logs pipeline. So you can see the schema. There's just one string that's coming in. We're not doing any parsings, and so we'll save this, validate, and then we'll publish. So once you publish the pipeline, and then we can go ahead and run the particular pipeline. So either what we'll be doing is just run once, but you can also schedule it to run at a particular frequency. So we'll just go ahead and run it once. And there are many different operational insights that you can get. For example, here you can see the logs that are coming from the actual jobs that are running. in background, it's actually running a MapReduce job, but you don't really have to know about that. But the logs are coming in. You can take a look at the metrics. We read 1,000 records, and the job actually completed. It took about 12 seconds. And then now we can go take a look at what actually the data looks like. So I'll go into the particular data set, execute a SQL query where I just fetch the top 5 records. So as you can see, the web logs look slightly similar to the sample data that I showed you before. So that all looks good. So now, let's say we achieved our first step. Now we will go back and try and do something a little more complex. So now I'll go to the old pipeline where we were just reading from S3 and then writing into HDFS. Now I'll just clone this pipeline. And now what I want to do is something a little more interesting, where I want to parse each individual strings into log files. So now I use this log parser transform, and I'll go ahead and configure that. The log, I choose the combined log format since I know that it's of that particular format, and then name the field. So in this case, body is the input schema that I want to parse, and this is the output schema where I get URI, IP address, the browser, HTTP status, and so on. So now that looks good. Then what we want to perform in this case is a group by aggregation, because what I want to find out is the status code distribution. So I want to group by the HTTP status, and I want to count the number of records for each particular status. So I fetch the schema. So this will be my output schema from the aggregate transform, where I get the HTTP status and then the count for each status. So now I want to process this data somewhere. So again, I'll use an file set to process it in Avro format. I can also label this better so that I know what it's doing. It's doing status aggregation. And this is the TPFS format. This restores the status results. And I can name the data set. And that's pretty much what I need to do. So I can take a look at the schema. So what we have here is a string that's coming in, and this is getting passed into this particular schema. The records are all parsed, and then finally here in this case we have an HTTP status and then just the count. So all looks good. Let's go ahead and publish this particular pipeline. I need to change the pipeline name. So this is going to be status logs pipeline. You can add a description too. That looks fine. So let's publish that. So now this will build a lot. I mean, this will again build another pipeline which will which will be physically implemented will be implemented 2 different MapReduce jobs. We can take a look at that. But the user doesn't need to know about that particular aspect. We'll get into that later in the slides. So I'll just execute this pipeline again. It'll go fetch that 1,000 records. So this is persisted in HDFS and then in a time partition file set. And at the same time, there's another branch where this gets passed and the status is getting aggregated, and then we will take a look at the status results as well. So similarly, as we saw before, we can get the metrics, and then so it looks like as we can see, there are 4 records that came out, and the pipeline run got completed. Let's take a look at the status results. We'll go ahead and issue a similar SQL query. So here we can see that for the 200 status result, which is all okay, the count was about 975. For 404, we had 6 requests which had a 404 response. So we are able to get a distribution of the state response status codes. So now this all looks good. Now let's try and increase the complexity a little bit more. We want to do something more interesting. So this is where we can really iterate again and again over the pipelines. So I'll go to the status logs. I'll clone this particular pipeline. Now I want to do something. Let's see. I'll try again. Okay. So here what I want to do is, now I want to aggregate by the browser information. So I'm just getting the past data from here, and then I'm just going to aggregate by a different field now. So let's go ahead and do that. So this is just the browser aggregate. And then I want to group by the browser fields, and I just want to count the number of records. And I get the schema again. Just go ahead and do that. So that looks good. And then finally, we will write it to a time partition file again. By the way, there are a bunch of other things that you can write to. You can write to HBase, you can write to Cassandra, you can write to RDBMS if you want to. For the sake of the demo, I just thought I would just use this. And then now these are all browser results. Right, that looks good. Then I'll change the pipeline name. All looks good to me. We can validate and then we publish. So as you can see, it's pretty easy to iterate over the design of the pipeline. So you can construct these logical pipelines, and then the underlying system, the Hydrator design takes care of implementing, creating those MapReduce jobs to run that in sequence or parallel and so on. So I'll just go ahead and fire up this run. And let's wait for, maybe it will probably take about 30 seconds. So at the meantime, we'll just go take a look at how this pipeline looks like. So as you can see, this pipeline is implemented using 3 MapReduce jobs. One of them is the first one that fetches the data and fetches data from S3. And then these 2 MapReduce jobs does the group by, so they can run in parallel because they're not really dependent on each other. And finally, it goes to the init. So as you can see, if we go back, there are 3 MapReduce jobs that were actually created to execute this particular pipeline. Let's go back to the Hydrator view. So the browser logs, the runs got completed. It took 33 seconds. Let's take a look at the results. We are interested in the browser results now. We want to find out what are the different browsers that the clients are using. So it looks like Chrome is the common, Chrome, and then followed by Firefox, and then some web crawler from Baidu. So that's basically how you can easily iterate over creating data pipelines using Hydrator. And I'd like to show you one last thing. So let's say I am satisfied with this, but then I want to choose which execution engine that I want to use. Let's say, so far we have been running MapReduce jobs, but let's say I want to run it using Spark. So it's actually pretty straightforward. All I need to do is I clone the previous pipeline, then I go into the pipeline configuration. In the engine option, I just choose Spark. And I'll just name this as Spark browser pipeline, and that's it. That's all you need to do to choose to run this pipeline using the Spark execution environment. And it's as seamless as that. I'll just fire up the run and then show you how it looks like. So if you go and take a look at this, it looks like exactly the same procedure, same workflow, and here you can see that these are 3 Spark jobs that are getting executed instead of MapReduce jobs. And let's wait for that to get completed. So exactly the same logic kind of is implemented using Spark. And meanwhile, while we are taking a look at this, we can also, what Hydrator allows you to do is using Cask Tracker, we can figure out lineage and metadata information. For example, let's say I was taking a look at the raw logs dataset. I can take a look at what are the different programs that are writing to my raw logs. So for example, this is the external dataset, and there were 4 different pipelines that we have created through this particular demo, and each of them are writing to different datasets, so you can kind of get that lineage information using Cask tracker as well. And let's go back to make sure that our job's completed. All looks good. So it ran just fine. Took 39 seconds to do that. So this is how simple it is to create data pipelines using Cask Hydrator. So I'll go back to the slides. So as you saw, we used the UI that we used to interact to create these logical pipelines, Hydrator pipelines. It's called as Hydrator Studio. As you saw, it was a drag and drop graphical user interface for creating data pipelines. We already have a rich library of pre-built sources, transforms, and things. We used a very small subset of that for this particular demo, but if you go ahead and open and explore it yourself, there are a lot of different sources and things and transforms that you can use. And as you saw, the pipeline creation is kind of different from choosing the execution framework. So that's kind of independent. So once you build your pipeline, you can choose to either run it using MapReduce or Spark. And we also have the ability to run real-time pipelines. We ran batch pipelines for this demo, but you can also run real-time pipelines, and you can choose to run it using Spark streaming, etc. But that's a feature that's upcoming. But that's the idea behind it. And it's also Hadoop native in the sense that it uses it launches like regular MapReduce jobs or Spark jobs. And most importantly, it's also Hadoop distro-agnostic. So you can take this and run it on, let's say you have CDH in a distribution, or if you have HGP, or if you have Azure, you can kind of use Cask Hydrator on top of any of these, build the pipeline on one particular distro, and then you can just port it that easily. And as you can see, this is the logical view of the Hydrator data pipeline. So as we saw, we can also capture metadata. We were able to capture lineage, and we took a look at visualize that using Cask tracker. And you can also have post-run notification. For example, let's say you want to get an email after your pipeline completes, or you can do that. You can easily add a post-run notification. And we also saw that there are centralized metrics and log collection. The metrics and logs from different MapReduce jobs or Spark jobs are collected, and you can use the UI to view all that in a centralized form. So you don't have to go into each particular container, each particular job to view all that. And if the pre-built sources, things, and transforms doesn't really satisfy your needs, we have simple Java API which allows you to build your own sources, transforms, and things. And the complete class server isolation. This is a problem that's often developers come across, where they use one particular library and then that conflicts with something else in your pipeline. So we provide complete class server isolation. And there are also some Spark ML-based plugins that you can drop it in to build your build models, machine learning models, and you can also classify data using the pre-built models. And there are also Python transforms that can be readily used by data scientists. So this is just a flavor of some of the out-of-the-box integrations that we have, like Elasticsearch, Cassandra, Kafka, and so on. And as I alluded to before, you can easily build your own transforms or plugins, source and sink plugins. Just an example, this is the abstract class that you need to kind of extend from to define your own transform. And as you can see, there's just one method that you just need to implement. You can build this and then upload it into Cask Hydrator, and then you're ready to use. So a Java developer in your team can kind of build this, and then other folks like data scientists or analysts can just use the Cask Hydrator UI to kind of build this, and they don't have to really worry about the underlying plugin implementations. So this is the hierarchy or the stack on which this is all implemented. Let's say we have the Hadoop ecosystem, on top of which we have CDAP, and Hydrator is implemented as a feature on top of, or extension on top of CDAP. And so we'll go into this a little bit more detail in the next slide. But as you can see, there are a bunch of different components in the Hadoop ecosystem. So if you want to develop the web analysis application that we discussed in this demo, you have the disparate components available, and so now we have to kind of learn each particular component, how to use them, how to stitch them together in order to achieve your complete business application. That's a pretty hard task. And what CDAP helps to do is it acts as an abstraction layer on top of this and provides you simple Java API to develop your application, and it takes care of and it works on any Hadoop distribution or most common Hadoop distributions like Cloudera, Hortonworks, and then that provides you with the abstraction integration layer, so you don't have to learn and understand each and every component to develop an end-to-end business application. Now, Hydrator is built on top of CDAP. Now, the goal of Hydrator, it takes up one specific use case, that's the data pipeline use case, and it allows you to build data pipelines code-free. You don't have to even write a single line of code. It's all completely graphical user interface based and drag and drop. So that's how simple it is. And when you provide this logical pipeline, when you're building this using the graphical user interface, what happens in the background is that a planner takes this logical pipeline and constructs a physical workflow. We kind of saw this when we took a look at the workflow diagram, where there was one MapReduce jobs and there was a fork and there were two MapReduce jobs that were running. So it kind of converts the logical pipeline into a physical execution plan, which consists of series of MapReduce or Spark jobs. It tries to bundle all those different transforms that you have in your logical pipeline into one or more MapReduce or Spark jobs, and it creates a CDAP application. And CDAP acts as an runtime where this particular workflow is run. And CDAP provides centralized log and metrics collection, which the Hydrator makes use of. So that's where the centralized log collection, metrics collection, complete transaction, lineage, and all that audit information are all collected, and Hydrator makes use of that to provide that features to you. So just have a little bit about the upcoming capabilities. We are working on some join feature across multiple data sources. So if you have different data sources and you want to join data across those two, so that's the join feature. We're working on pipeline previews, macro substitutions, and we're also working on pre-actions in pipelines similar to the post-run notification that I talked about, where you get an email after the run ends. And we're also working on Spark streaming support for real-time pipelines as well. And that's the end of the talk. I'll probably take any questions.
I noticed that your speed was not very high. Were you actually running the demo on your client machine, or were you working with the server as well?
So the demo that I ran was on my laptop. So the Cask Hydrator or CDAP has a standalone mode where you can run it on your laptop, build pipelines and all that, and then you can run that exact same. You can get the same pipeline and run it exactly.
And you distribute it across multiple servers using Mapper. MapReduce?
That's correct. Yes.
So that would be the way around your speed limitation?
That's so you don't really want to run like millions of records through your laptop, but that's something, if you want the scalability, you can run it on your.
Is there an overhead associated with Cask?
Not really, no. So what it does is basically just summons a yarn application, and then the MapReduce job is Spark job that runs on it. So so what I ran was on my stand. Any other questions?
So each node in the data pipeline represents an intermediary data set, right?
Yes, you can logically think about each node in my logical pipeline. Yes. So yeah.
So where are these intermediary data sets stored?
Oh, so for example, let's say I'm performing group by, and then let's say I'm performing some projection where I'm dropping some fields, or let's say I'm dropping some fields and doing some group by projection. So these two can be combined into one particular MapReduce job. So you don't have to store any intermediate results. But that said, as you saw, there were one MapReduce job, and then there were two MapReduce jobs that were after that. So there are some intermediate data sets that are persisted, and we use we insert local data sets, and those are stored in HDFS, and that's once the run completes, it's all cleaned up by the platform itself. So it's kind of, you don't have to worry about that. Those local data sets, the intermediary data sets are inserted by the platform, and they are cleaned up after the run completes.
So in other words, actually, when you clone a data pipeline, you don't really have any actual data to clone, right? You clone the logic clone.
Yeah, I'm cloning the logic. Yes.
Of the flow.
That's right.
So what's the trade-off between using Cask and cascading?
Cascade, okay. So that's probably a longer discussion, but so unfortunately I'm not familiar with cascading's offerings and products, so I'm not be the right person. But you feel free to just talk to any of us after the. Any other questions?
Nobody has. Okay. Yeah, I can go last.
I'm just interested. Usually Spark is faster in general because it doesn't need to cache intermediate steps on the disk as MapReduce do.
Right.
Like I saw your default is MapReduce. Is there any defaulting to faster or some optimization?
So the Spark feature was introduced fairly recently to the platform. But that said, you'll have to think about whether you get faster speed or not. Probably depends upon your logical pipeline that you're building. But right now, the choice of whether you want to run on MapReduce or Spark is left to the user. Maybe in the future, the platform might be intelligent enough to choose one or the other based on the platform.
Spark is still optional on the platform, so you have to run Spark. That's why we default to MapReduce, because it ships to Hadoop.
So you
Yeah, congratulations on a very good talk, and I'm a bit chill too, so I already like your talk. So I'm new to this ETL field, extract, transform, load. So where exactly this all fits in, and where can I use it?
So it's specifically, the most common case is the ETL use case, right? So as you can see, it lends itself well into the ETL application. So a lot of our customers are actually using Cask Hydrator to develop this. But then where it kind of differs, it has a lot more capabilities in the sense that you can use those aggregations, you can build models using the Spark ML plugins. And not only that, since Cask Hydrator is built on top of CDAP, now ETL is like the kickstarting problem. That's what usually people are doing right now with Hadoop. But maybe in the future you want to build something more interesting and into an application. Now you can use maybe Hydrator does not fit all your needs, and so you can go to CDAP one layer below, use the Java API to build a complex application, and it's still a lot more easier to develop, and you get all the benefits like the Hadoop distribution agnostic and then log collection metrics and so on, and you can build fairly interesting big data applications using CDAP.
This is not open source, I have to buy.
I'm sorry, actually, probably.
I mean, I don't have any money, so I have to ask that.
Right. So it's all completely open source.
Cool. Thank you.
It's free. You can go to GitHub. All the Jiras and the development, everything is all open, so you can take a look at it. And contributions are of course welcome and so on. So if you take a look at our Jira as well. So feel free to download the SDK and build it.
Thank you.
Any other questions?
Is there any other way to query the data other than the SQLite language? Like search or?
So SQL. So we do provide this SQL interface to query the data. But then depends on where the data is landing. So for example, let's say if it's going into HDFS, then you can probably go and log in and just do an Hadoop file system commands. Or let's say if you want to fetch data, for example, if you're writing to RDBMS directly or Cassandra or Elasticsearch, you can go into that particular sink or source to fetch the data. Are you looking at a programmatic way to access the data, or are you looking at
more interactive interface?
Oh, I see.
Rather than SQL.
I see. So So currently, SQL is probably the easier way to kind of do it from the CDAP platform itself. Maybe depending upon for example, if you have Elasticsearch destination and you have a UI put on top of that, maybe you can interact with that data directly. But you can talk offline to figure out if there are any other use cases. Yes.
terms of benefits, I can see that having a drag and drop interface has obvious benefits. You're trying to introduce a level of abstraction which can be independent from what you're actually doing with the execution of the code. But one of the problems with drag and drop interfaces has always been maintainability. So how does Cask handle the issue of, okay, you build your application and then you have to maintain it? What tools are available for maintaining it?
So that's a great question. So one of the ours is an enterprise product in the sense that we take very seriously versioning of the system, or versioning of the software product. So we make sure that we provide backward compatibility with the previous version. Let's say the UI version.
I was really thinking more about complexity.
Oh, okay.
When you build a simple application with drag and drop, it always looks good. It's great for sales demos.
Right.
But how complex can Cask be and still be usable?
I think currently there's really no limitation on the complexity of the pipeline complexity that you can build using the UI. In order to maintain you can export the particular pipeline that you have built into a JSON file that you can maintain, and then you can use that. If you think about like source code versioning of that particular JSON file.
So you can have objects and combine them, and the object has a graphical representation, and so you're trying to maintain at a lower level of complexity.
That's right.
Okay, got it.
So probably I'll leave that as the last question. Thank you.